This is the Building Automation Monthly Podcast with Phil Zito, episode 133. Hey folks, Phil Zito here, and welcome to episode 133 of the Building Automation Monthly Podcast. And in this episode, we will be discussing the 5 steps for effective BAS takeoffs. So if you've never listened to the podcast episode before, welcome. My name is Phil Zito. I'm the founder and CEO of Building Automation Monthly, where we provide online training to BAS professionals to help them increase their productivity and profitability in their building automation careers. So in this episode, we're going to be tackling a question that I've received a lot through email. I've seen it on LinkedIn, just in conversations with folks. And if I'm honest with you, if I'm transparent with you, for the longest amount of time, I thought to myself, how do I tackle this? Because there's so many intricacies in takeoffs. There's so many different moving parts and pieces. I know when I was a tech, I used to joke around, sales, they just golf and that's all they do. But, as I started to move into sales support roles and sales roles and just being more engaged in the selling process, I started to realize that there is a lot there. And if you think that the desert is dry when it comes to BAS technical training, when it comes to BAS sales training, that's like Mars dry. At least from a technical perspective, there's a little bit of stuff out there, but for a salesperson, when it comes to doing takeoffs, oh my gosh, there's nothing there. So what are takeoffs and why are they important? Well, takeoffs quite simply are the process of evaluating a job design and then scoping out the project. So whenever you're in sales, at least for new construction, you're typically given design documents. And you see those design documents, and from that, you need to create a scope of work that you can then price, and hopefully you price it right, so that your team can win the job and can execute the work. Now, over the years, I've seen a lot of different ways to do takeoffs. I've seen a lot of different things that worked well. I've seen a lot of things that worked not so well. And in this episode, we are going to unpack 5 steps that, when properly applied, are going to make doing takeoffs much, much easier. So step 1, we need to understand the job. Now, I know this may seem pretty basic, as most of our steps do, but the beauty lies in the details. If you have ever sat in a sales to operations handoff and have talked to the salesperson and been, so tell me about the job, and they couldn't really tell you about it, that's a scary place to be. And if you're the salesperson and you're trying to answer questions related to a job, that's a scary place to be. But has anyone ever really taught you, outside of just the school of hard knocks and experience, how to really understand the job? I mean, how do you do that? If I say understand the job, what does that mean to you? Well, I've got 3 steps inside of this step that will help you do that. Number 1 is to read the spec. Now, I know that feels like pulling teeth out, but we're not saying read the entire spec, although I know some salespeople who do, but we're saying read the spec for specific things. So as we know, a specification is typically broken out, at least here in the States, according to 3 areas. You've got general conditions, you've got products, and then you've got execution. Those are the 3 areas of a specification. Now, as a salesperson, you could take value from each of those areas. For example, when we were creating our control submittal course, where we teach folks how to create control submittals from scratch, we used a sample specification. And as we got towards the middle of the products section, every single sensor was 4 to 20 milliamp, 1K platinum sensor. Now, if you know anything about pricing individual sensors, you know that that is the difference between a $10 and in some cases a $100 sensor. On a site that has hundreds of thousands of square feet, that can add up to a significant cost difference. That can be a competitive advantage for a salesperson who reads the specification, understands that 4 to 20 milliamp sensors for duct probes is probably not necessary. I would argue it's not necessary at all. That being said, you go and you submit a request for clarification or a request for information, and you're able to adjust your scope of work. Now, I know on some projects, all RFIs and RFCs become public knowledge, and so you're actually helping your competitors, but that's assuming your competitors go and read the RFIs and RFCs and aren't sitting in there playing toss a number and just hoping that they're low. By reading the spec, you're able to identify things like that, hidden requirements, and areas of opportunity. You're able to see places where maybe you don't need that expensive $1,000 controller. Maybe you can actually use the onboard BACnet IP communication from the piece of equipment itself. It's through reading the specification that you are able to go and understand the job. But you've also got to know the engineer and the owner. Engineers, just like controls companies, become known for their area of focus. I remember a job I was working on for a high school. And typically high schools are air handlers, chilled water central plants, and VAV systems because they're very large. However, this engineer was known for their rooftop units. And because of that, he specified rooftop units for every classroom in this high school. Now, I'm not going to get into whether it was ridiculous or not to have a 2.5-ton rooftop just covering the roof of this high school, and whether it would have been more efficient to just have a built-up air handler and a chilled water plant, but that's what this person did. Knowing that, however, you're able to work with your mechanical contractor to get those rooftop units to have BACnet IP cards or BACnet MST cards coming out of the factory. That gives you a distinct pricing advantage. Also, knowing the owner and knowing their expectations. There's nothing worse than going and you work really hard to win the job only to find out that the owner has been courted by someone and you didn't see that coming and you lose the job. And finally, know the vertical. So you need to read your specification. You need to focus in on areas of profitability. You need to know the engineer and the owner, but you also need to know the vertical. You see, there's certain things you can do with commercial real estate that you can't do for a hospital or an FDA-compliant manufacturing site or a Tier 4 data center. Knowing your vertical gives you a distinct advantage because you know where you can flex in your price and where you've got to be very, very risk conscious. Because at the end of the day, if you become known as the person who change orders the mechanicals to death, or you become known as the person who can never execute work because you improperly scoped the job, you're going to real quickly, especially with how small this industry is, you're not going to be a well-respected salesperson. Which brings us to step 2, and that's using the documents. As I mentioned, there are 3 areas within a specification that we want to focus in on. We want to focus in on general, products, and execution. We also need to understand the conditions of the project. Is this public money? Is this private money? Is this a compressed timeline? Now, I know at this point you're thinking to yourself, Phil, you said we're going to learn about takeoffs. And we're going to learn about, because when I say takeoffs, most of you envision looking at a set of mechanical drawings and going and counting the number of VAV boxes, looking at the equipment schedule, and determining the amount of product. And that is true. That is part of takeoffs. But I would argue that another part of proper takeoff and scoping of a project is really understanding the project and where you can flex in your scope. Because if you understand the conditions of the site are such that it would work for a wireless system, for example, it's big open bay areas, then you can go and potentially have an add alternate of wireless and have a deduct built into that because of the lower electrical cost. Also knowing the schedule, the compressed time schedule, knowing what that value of being able to execute that is. And finally, knowing if there is existing sites. Tying into an existing site gives you many advantages properly used. For example, if you are expanding on a job that you already have the existing head end in, then that gives you a distinct competitive advantage. You can duplicate your graphics. You can duplicate programs. You can use the existing server. You can use the existing network. All of those are cost reductions that you need to account for in your project scoping. Which brings us to step 3, which is identifying the unknowns. And this is something that I would say it comes with time, and to a point it does, but it really is in your frame of thought and really understanding core system functionality. What I mean by that is, let's look at a couple logical failures. When I say logical failures, I'm not talking about control logic. I'm talking about thinking logic. So you have an air handler that is water cooled. But as you look at the MEP plans, as you look at the specification, as you talk with folks, there is no chiller. There's no central plant, yet the air handler is water cooled. How is that going to function? How are you going to make that work? That is an example of a logical failure. Let me give you another one. You have a staging sequence for a series of boilers, or a staging sequence for a series of chillers, but there are no controls. Once again, how will that work? How can you follow a sequence that says, look at all the valve positions and stage up and down the chillers when there are no controls on the central cooling plant? That is a logical failure. Now you could just say, hey, they didn't call it out. I'm not going to scope it, and that's fine. You can do that, and that would potentially make you low. Or you could go and actually provide value to either the specifying engineer or the mechanical. I'm not going to get into strategy-wise whether it makes more sense to go to specifying engineers and win them over, or makes more sense to go to mechanical engineers and win them over. It really depends on your geography as to which one of those partners will have a more profound effect on you winning the project. I will say, however, that the last thing you ever want to do is go blast your partners. You don't want to go make them look like idiots. But on the same token, you can go and talk to them and explain to them this concern privately, and that will provide tremendous value. You also want to look at existing conditions. You want to understand what existing conditions exist. I know that seems redundant there, but think about it for a second. If there is an existing building automation system, how does that impact your scope? If there is an existing BACnet IP system that you need to integrate with, maybe a lighting system, maybe some sort of power monitoring system, how does that impact your scope? Oftentimes, when I deal with folks who are scoping and doing takeoffs, they get the VAV box count right. They get the air handler count right. They don't mess up on that. That's pretty obvious. Where they tend to miss things, where they tend to get burnt, is on these secondary systems or on these logic failures. They tend to miss those, and because of missing those, they don't do the most effective takeoff that they could actually do. Now, the other area that I want to point out, an area that you got to be careful with, especially in this day and age. I didn't see this as much when I was starting off my career, but it seems to be much more prevalent now. It seems like every trade has their own smart building system. You have smart boilers, smart air handlers, smart lighting, smart everything. And because of that, everyone is expected to integrate with everyone else. Now, this isn't always the case in a lot of plan and spec work. But when you get out of that and you start to move into design build or integrated projects, that's where you start to see conflict on multiple trades that are providing, quote unquote, I'm making air quotes here, you can't see them, controls equipment. So you need to identify those unknowns. All right, now step 4. So up to this point, right, we've understood our job. We've used the documents to go and figure out, what parts and pieces do we need, what conditions, where are the logical failures, what are the existing conditions, what potential issues could we run into. Now we have to determine our efficiencies because, let's be honest, most of construction work is being the lowest person. It's not, it'd be nice to have it be the person who provides the greatest value, the person who can go and execute the work the best. But at the end of the day, for most of the plan and spec work out there, it's can you be lower than everyone else? Do you have any favors that, a couple people owe you, you were low for them on a job? Because how this all works, right, is the mechanical is going to go pick his subs, and if they haven't been selected, and is going to try to go and be the lowest mechanical with his sub package. Now, in some cases, the mechanical has already been selected and they were selected at a given price, and now they need to try to fit contractors under them at a given price. And the name of the game is you've got to be the person who can fit under that price. So how do you do that? How do you go and reflect that cost sensitivity? Well, you do it by determining efficiencies. And there's a couple ways you can determine some efficiencies. One is by reading the notes. I'm still constantly surprised how many folks don't go and read the notes in mechanical plans, the notes that say BACnet IP interface or dampers and valves provided by controls contractor or not provided by controls contractor. Reading those notes will give you potential areas where you can shave 1 to 3% off of your total cost of material. From there, you have bundling strategies. This is where you work with the mechanical to potentially bundle controls as part of a package. This is where you go and you provide equipment with controls factory mounted. This is a way of reducing install costs. You also have ways of generating efficiencies by providing the minimal viable product. Now, I'll be honest, this can backfire on you, so use this strategy carefully. Flats. I remember working with a college that we were flat spec'd on, and the mechanical had brought in someone else as an alternate, even though we were flat spec'd. And this person came in at $30,000, and we were $100,000. And I sat down with the VP of facilities, and he was saying, Phil, I like you guys, but you're $70,000 more. And as we started, I said, okay, well, what about just showing me the scope of work that this other group has? And before you judge me and go, oh, man, you're looking at someone else's scope. He crossed off the price, so I didn't see their price. But also, you know what? You're lying to yourself if you think other folks don't do the exact same thing. So be aware that if you can get competitive intelligence, get competitive intelligence. Don't be unethical. Don't go and take people's proprietary knowledge. But, if you're really, truly trying to serve your customer and someone comes in $70,000 below you and you're not ripping them off, then you know that this person who's coming in is trying to give them a inferior solution in most cases. Some cases, they may just be providing a better price or have better efficiencies, but most cases, they're skimming somewhere. So as we started to dig into this, we found out that instead of providing controls, they were providing electromechanical thermostats that had BACnet built into them. So these were basically wiring up to a rooftop like you would do at your house, and they had a BACnet interface, and that was their controls. Whereas this customer required DDC control for their building automation system. And that is a huge difference, my friends, in capabilities. And because of that, we were able to show that cost difference and win the project. So you can definitely take a minimal viable product approach, but you need to be careful whenever you use that efficiency strategy. And step 5 is to accept the 90%. You've got to be comfortable with being great enough. I didn't say good enough. I said great enough, because I don't think good enough is good enough. Good enough is 70%. It's 60%. You're throwing a swag out there. Be great enough, but you don't have to be perfect. Meaning, make sure you've got the right supervisory device count. You're accounting for electrical costs. You've got the right controller count. But if you miss a sensor here or there, that's fine. You want to focus on the big rocks, though. Where could you potentially do integration? Where could you potentially do factory package controls? Where could you potentially take advantage of existing site conditions? These are all things that I want you to think about as you approach your takeoffs. So no, we didn't approach takeoffs from the traditional steps of, hey, go count your VAV boxes and get a controller count, and then count your sensors and add them up. However, I will tell you from experience that these 5 steps, when followed, will really help you be significantly more competitive than the other folks you're selling against. So with that being said, I want to hear what you find to be some great strategies and steps to use during the takeoff process. How do you find yourself being more competitive? What do you wish you knew when you first started? Go to buildingautomationmonthly.com/133 and let us know in the comments section. And if you find yourself wanting that HVAC knowledge, wanting that BAS fundamental knowledge, so you have credibility when you step in and talk to a customer, when you talk to a contractor, you don't want to have to worry about if they call you out on something, then I would encourage you to check out our Building Automation Systems A to Z program. It will give you that knowledge you need so that you can be confident in your abilities when you work with your customers. So you can check that out at buildingautomationmonthly.com/133. In next week's episode, we are going to go and dive in to the 4 gotchas of power. So as I mentioned in episode 132, we're cycling through 4 different themes. So every 4 weeks we cycle through, and last week was on management, this week is on sales, and next week is on technical skills. So we'll be talking through power and the common issues related to power as a controls technician. Thanks a ton for being here. Can't wait to talk to you again in next week's episode. Take care.